Up to now we saw how Bayesians do inference about parameters. The question is, can Bayesians predict the new observations, predict what will happen in the new experiment? And the answer to that would be discussed next in Bayesian prediction. Recall that marginal distribution is the integral of the likelihood times prior. Now, this marginal distribution is sometimes called the prior predictive distribution because it involves the distribution of x's. If you take the expectation, or if you take the integral of the likelihood with respect to the posterior, then you call this posterior predictive distribution. I purposely denoted this argument not x, but x plus 1 to emphasize the following. Let's suppose that you have n observation already collected, and for this n observation and prior, you find the posterior. And then you are about to collect the n plus first observation. You may predict, using posterior distribution from the previous n, what would be expected value and what would be distribution of this n plus first observation. The distribution, predictive distribution, would be simply the integral of the likelihood of this n plus first observation times the posterior distribution. That is posterior predictive distribution. Now, the very prediction itself is the predictive mean. It is the mean with respect to this predictive distribution. Analytically, that would be integral xn plus 1 times the posterior predictive distribution of xn plus 1. The variance, predictive variance, is defined in usual way. It is simply the difference squared integrated with respect to the posterior predictive distribution. The best would be to take a look at the example and see what would be posterior predictive distribution for the following case. Imagine that we observed n exponential random variables. Parameter lambda is unknown, and on parameter lambda we put the prior with hyperparameters alpha and beta. The posterior distribution, we found this in the past, it is going to be again gamma distribution, but with parameters alpha plus n and beta plus summation of xi's. Now, the posterior predictive distribution would be simply the likelihood. In our case, this is exponential distribution, lambda e to the minus lambda xn plus 1. So we are looking for posterior distribution, posterior predictive distribution for the xn plus 1 times the posterior, and this posterior is gamma. We end up with essentially expression which is finite. It has finite form, and that looks like Pareto distribution. The xn plus 1 plus summation of xi plus beta is Pareto distributed with parameters summation I from 1 to m xi's. This is the previous data, observed data, we know that, plus beta, and the m plus alpha is the other parameter. Just for reminder, X has Pareto distribution with parameters, hyperparameters c and alpha. If the density is alpha over c, c over x, quantity raised to the alpha plus 1. The expectation will be needed for the prediction, which is alpha c over alpha minus 1, and the variance is also given for Pareto distribution. So we found that in this case, for the exponential observations and gamma prior, the posterior predictive distribution is Pareto. It's sort of scaled Pareto, because we have this scaling by summation of xi's plus beta. So what would be our prediction? Our prediction would be expected value for xn plus 1 with respect to this posterior predictive distribution. And if we take the expectation of Pareto, we find that this is summation of x's plus beta divided by n plus alpha minus 1. So that would be the expected n plus first value if we already observed n values. As an exercise, you may try to show that the variance for the predicted xn plus 1 is given by this expression, which is here. Let's take a look how this works if we have the specific example. Assume that these are exponential, let's say lifetimes. Exponential distribution models very successfully lifetimes if there is no aging of the equipment or if the aging is minimal. So let's suppose that we have these 7 observations from 2.1 up to 2.3. And let's suppose that we put lambda to be gamma distributed, this is our prior, then show that the prediction for the 8th observation would be 9 over 2, and show that the variance of that prediction would be about 26. Now, if only expectation is needed, you may want to have simple formula. It is simply the mu of theta, which is the mean of theta, as a functional parameter, evaluated with respect to the posterior distribution, integrated with respect to the posterior distribution.